Hello class, today's section is the standards Trigonometry 2.0. I'm going to teach you about the unit circle. The unit circle is a way, or it's a sort of like a cheat sheet for you all to figure out differences between radians and degrees, and also find the measure or the actual value of a certain degree measure or the certain radian measure. Normally you'd have to use a calculator, but this unit circle, or the reason why they came with the unit circle, is to help you all find stuff very easily, very quickly without having to use a calculator. And for some of you, I'm pretty sure you'd rather use the calculator. So you guys see, here's a unit circle. And remember, if you remember from my last video, it's been a while, but the unit circle or the degree measures always start at this point right here. Okay? And as I go around the unit circle, I have different degrees and different radian measures, and we're going to fill in this blank unit circle. First of all, on the unit circle, or what the unit circle is a circle that has a radius of 1. So all these lines starting or originating from the origin all have a length of 1. So the unit circle literally means a circle with a radius of 1. Well, if this is a circle with a radius of 1, this point right here, remember we're starting at this point, would you agree with me that this point is 1 comma 0? Yeah, because I go a unit of 1 over. If you believe me with that, you would agree that this is 0 comma 1, and this would be negative 1 comma 0. And then the one down below, I know it doesn't fit on the screen, would be 0, negative 1. So those are the main numbers of the unit circle. Okay? Since this is how the unit circle begins, this is 0 degrees, and this is also 0 radians. Okay? That's that measure. Over here, if I turn, or I create an angle, do you see how this is like a perfect corner? If you remember your geometry, if I go over this many in this corner, that's 90 degrees. So this represents 90 degrees. Or in radians, if you remember, or if you want to quickly refer to your conversion, 90 degrees is also pi over 2 radians. Now, if I start from here and go all the way to the other side, this represents 180 degrees. So I'm going to go all the way over, and I'm going to call this 180 degrees. And if you remember your conversion factor, 180 degrees is pi radians. I told you we're missing, well, the screen is too, well, how about this? Let me scroll down real quick. If I go all the way down across, not 90 degrees, 180 degrees, this becomes 270 degrees. And in radian measures, that's 3 pi over 2, or a pi and a half. And if I go starting here and go all the way back around the circle, that's 360 degrees, or in radians, that's 2 pi. So the very first part of the unit circle that you should know how to fill out, again, this is just a cheat sheet, you should be able to do these 4 points pretty quickly. Okay. The next one you're going to do very quickly is this quadrant right here. If you remember back in Algebra 1 and Algebra 2, this is called quadrant number 1. Okay. How do you fill this in? Well, if you remember the special triangles from geometry, remember 30, 60, or 30 degrees, 60 degrees, 45 degrees are the special angles. So in the unit circle, they only talk about the special angles. We're not going to learn about every angle in the unit circle. All we care about is 30, 45, and 60. Those are the special triangles, the special angles you should have learned in geometry. So 30, 45, 60, those are the ones that you care about and should know about. In radians, just to teach you, and again, you can convert this on your own, but it's just easier to listen. 30 degrees is pi over 6 radians. 45 degrees is pi over 4. And 60 degrees is pi over 3. I sort of remember it because, 45 degrees, pi over 4. They both have a 4. And then the 3 and the 6's are always reversed. So 30 degrees is pi over 6. 60 degrees is pi over 3. Okay. Now, we did the value for 1, at 0 was 1, 0. We did the value at 90 was 0, 1. But how about these values? How do we do it? Okay. You could do this the long way. I could teach you the long way. Or you could just sort of, I have a shortcut for you guys to remember. This is how it works. You fill in, starting from the top left, like you're writing a letter, and I'm going to go 1, 2, 3. Okay, so far? So start at the top left, 1, 2, 3. Then I continue on to the bottom right, and they alternate. It's going to be 1, 2, 3. Okay, so far? That's the numerators for these values. The denominator for all of them are all going to be 2. Okay. So remember, this is a shortcut. You don't need to know why this is happening. You don't need to, be curious of why we're doing this. Again, this is just a shortcut. And then lastly, I'm going to do a square root of all the numerators. So the square root of 1 is 1, so I'm going to leave that alone. The square root of 3, I will label it. The square root of 2, square root of 2, square root of 3, and remember the square root of 1 is 1. Now how do you use this? How is this a shortcut? How is this supposed to make my life easier? Alright, write this down on your notes. The x value represents cosine, and the y value represents sine. So this is a review from geometry, and some of you that are taking physics should know this also, but I'm not going to teach this or reteach it to you guys because it was a geometry thing. But just know that the x-coordinate is the cosine value, and the y-coordinate is the sine value. So now you have a nice shortcut here, and this is how it works. If I say, hey, person, what is the cosine of 60? Well, go to where it says 60. Remember, cosine is the x-coordinate, so I could say the cosine of 60 is 1/2. That's how powerful the unit circle is. If I said, hey, what's the sine of pi over 4? Here's pi over 4, and the sine is the y-coordinate, so it's radical 2 over 2. See, pretty cool. Well, you guys don't think it's pretty cool, but it's pretty fast, and it's faster than even using a calculator. So to repeat, all we did the special degrees, 30, 45, 60. We converted this into radians, pi over 6, pi over 4, pi over 3. We then did, again, this is just a shortcut, 1, 2, 3. Then going back up, 1, 2, 3. We put them all over the denominator 2. And then we square rooted all the numerators. We didn't put 1 over 1 because the square root of 1 is 1. So if I say, hey, what's the sine of pi over 6? Here's pi over 6. Sine is the y-coordinate. You could tell me 1/2. And that's how powerful the unit circle is. And don't think that I invented this or it's really nerdy. This is something that all calculus and pre-calculus students across the world are doing. Now some of you are wondering, what am I going to do with the rest of this unit circle? What am I supposed to do? Well, using your skills, you could actually deduce what radian measures and what degree measures these all are. Okay? Let's do the simple one first. See how these are matching? Like they're about at the same height, but it's on the other side of the x-axis. So this one, you'd agree, is the exact same coordinates as this one. So this is 1 over 2, radical 3 over 2, right? Exact same coordinates. They look and they're at the same height. But the difference is that, do you see it's on the left side of the x-axis? Remember how this side is the negative? So this is the exact same thing, except for this is -1/2 positive radical 3 over 2. Okay? So do you agree in this quadrant, it's exactly the same values as this quadrant, except for all the x values are now negative because I'm on this side of the x-axis. So instead of radical 2 over 2 and radical 2 over 2, this one will be negative radical 2 over 2, and positive radical 2 over 2. Instead of in this quadrant radical 3 over 2 and 1/2, this one will now become negative radical 3 over 2 and 1/2. So just to repeat, this quadrant is exactly the same as this quadrant, just that the x values are now negative. Looking below, and I'll fill in the degree and radian measures a little bit later. Remember in this quadrant, both the x and the y coordinates are negative, right? So any number, any value in this quadrant, both x coordinate and y coordinate are both negative. Now, it's a little bit changed up. Do you see how this coordinate right here lines up with this coordinate right here? So it'll have the exact same values, except for they'll both be negative. And sorry if it's messy. Okay. On this one, you see how this coordinate lines up directly with this one? So this one's negative radical 2 over 2 over negative radical 2 over 2. And lastly, this coordinate lines up nicely with this coordinate, so it'll be -1/2 negative radical 3 over 2. And the final quadrant, you'll notice that in this quadrant, the x coordinates are positive and the y values are negative. So again, I'll follow along. I could copy along this way. I could copy along this way. I'll just go ahead and do this way. Do you see how this point right here lines up with this point right here? This will be positive radical 3 over 2. It's a positive x coordinate, and it'll be a negative y coordinate. So instead of positive half, this one will be -1/2. And I'll fill in the rest. Positive radical 2 over 2, negative radical 2 over 2. And Again, lining these up, I get a positive half and negative radical 3 over 2. So the last one you want to do is you want to fill in the radians and the degree measures. For you guys, you're going to love, or not love, but you'll think that it's really easy to do degree measures. So do you see how this is 30, this is 60, this is 90? Which means this will probably be 120. This will be 150. I'm skipping the one with 45 degrees. This is 180. This will be 210. You see how I'm just adding 30s? So 120, 150, 180, 210, 240, 270, 300, 330, 360. So going around 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. So that's pretty easy. All I have to do is add 30. 45s, I'm adding 45. So this one's 0, 45, 90. 90 plus 45 is 135. 180. 180 plus 45 is 225. 225 plus 45 is 270. 270 plus 45 is 315. So now we have done all the degree measures. Again, it's simple addition to get the rest of these degrees. But the one that you're not going to like, the one that you're probably going to say, oh no, is how do you do radian measures? Okay. Same thing. Remember how I added 30 all the time? Instead, what I'm doing is I'm adding pi over 6 every time. So do you see this is 1 pi over 6? This is technically 2 pi over 6. This is technically 3 pi over 6. So this one's going to be 4 pi over 6. 5 pi over 6. Oops. And this one is 6 pi over 6. Okay, so all I'm doing is adding pi. Remember in degrees, all I did was keep on adding 30s. Well, now I'm just adding pi over 6s. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Okay. Now I will do 7 pi over 6, adding another pi over 6, 8 pi over 6. This one is technically 9 pi over 6, 10 pi over 6, and 11 pi over 6. So the one thing that you want to notice, or that you might notice, is that some of these can actually be reduced. Some of them are reduced for us already. But see this 4 pi over 6? I'm going to rewrite that to be 2 pi over 3, right, when I reduce it. This one over here, do you see 8 pi over 6 can be reduced to 4 pi over 3? And this one over here, it says 10 pi over 6 can be reduced to 5 pi over 3. So for you, you want to use the reduced versions, but I did the bigger version so you can see how easy it is to add the rest of them. Pi over 4, last one, is I'm adding pi over 4 to everything. So pi over 4, this is 2 pi over 4. This will be 3 pi over 4. You see how this is 4 pi over 4? This will be 5 pi over 4. This is technically 6 pi over 4. This will be 7 pi over 4. And lastly, this is 8 pi over 4. So that's how you fill in the unit circle. I know that in this class, when you go through these videos or take the notes at home, it might be a little bit confusing. That's why we take the next day to go through some examples, to some exercises, do some activities in class so you get it. But this is just to give you a base foundation. I don't expect you to understand how to do this, but what you should be able to understand to get a perfect on the standard is know how to fill in this unit circle. And then if I tell you or ask you any value, you know how to do it. So if I say, what's the cosine of pi? I look for pi. Cosine is the x-coordinate, so cosine of pi is -1. Or if I say, hey, what's the sine of 11 pi over 6? I look for 11 pi over 6, and the sine is the y-coordinate, and this is -1/2. So to master this standard, you need to know how to fill in this unit circle and be able to find the value asked for, so like a cosine or a sine. So I hope you enjoyed the video. Make sure you answer the questions on the quiz, and I'll see y'all in class.